Angle ACB is 90 and CD is perpendicular to AB. Prove that BC square over AC square equal to BD over AD. Now we need BC square, so we're going to take this triangle BCD so that we get BC square, and take the entire triangle, the larger triangle ABC. Now by theorem we know these two triangles are similar. We have learnt earlier, let me just go over that. If I have a right angle triangle and here there will be another 90 degrees, I have three triangles here, 1, 2 and the entire big triangle. All these three triangles are similar. So I'll take triangle BCD and I'll take triangle BAC, and we prove that they are similar. Now here you see angle B is common for both. This is angle B, it's present in both the triangles. So I write angle B is equal to angle B, that is common. So I'm done with angle B and here angle B. Now we see the 90. In BCD, in the blue triangle, here is 90. Here. And in the big triangle, we have C is 90. Equal to 90. So now I'm done with these two. I'm done with B and C. Now I'm last left with C should be equal to A. The C in this small triangle, which we have already learned, this triangle equal to A. So we have C equal to A. We write three letters for this. So angle DCB equal to angle A by angle sum property. So these two triangles are similar by SSS test. Triangle BCD similar to triangle BAC by AAA test. So I can write now BC over BA equal to CD over AC equal to BD over BC, and I require BC square. So definitely agree, I don't require this, I require only the first and the last ratio. So I have BC over BA equal to BD over BC. Now cross multiply, I will get BC into BC equal to BD into BA, which means now BC square equal to BD into BA. This is equation 1. Next we take triangle ACD and triangle ABC. The large triangle ABC, this large triangle, with this smaller one, that is CDA. Now here again we see the common, which is common for both, and we see that A is common for both, so we write angle A equal to angle A. So we are done with this. The 90 degrees. In the small triangle, here is 90, D is 90, and in the larger triangle C is 90. So we'll mark that. Here we have D 90 in the smaller, and in the larger one we have the full angle C, so angle ACB is 90. Then we have the third one that is left, so we can say now that this C here is equal to the B. So angle ACD equal to angle B. And if you recollect, we have like this three right angle triangle, one right angle triangle, and here two more right angle triangles. If you recollect, we had done this last time, that this angle was equal to this always, and this angle was equal to this. We had proved this. Similarly, if we have a case in this manner, 90 degrees, and here again we had 90 degrees, and here too I could say here angle equal to this angle equal to this. You must remember this, and we had proved it in the earlier proofs. So now we have angle ACD is similar to, triangle ABC. So AC over AB equal to CD over BC equal to AC over AD over AC. Now we need to find AC square. Our AC square, so we're going to take this away. We don't need that. So AC over AB equal to AD over AC. We cross multiply. AC into AC equal to AD into AB. AC into AC is AC square equal to AD AB. Equation 2. So the next part of the sum, we had two equations, BC square equal to BA into BD. This was our equation 1 that we proved. And now we have proved AC square equal to AB into AD. I will divide equation 1 and 2. On dividing, we have BC square over AC square BABD over ABAD. Now AB will cancel, and we'll get BC square over AC square BD over AD, and we have proved. A ladder is placed against a wall such that its foot is at a distance of 2.5 meters from the wall, and its top reaches a window 6 meters above the ground. Find the length of the ladder. So first we have the wall. AC represents the wall, so we write this. AC represents the wall, and we need the ladder. Here AB will represent the ladder. Now we need to find the length of the ladder. So here is our x, and they said that it reaches 6 meters above the ground. So C is the ground, and now the ladder reaches 6 meters above, which means this is 6 meters right here. From the ground to the top of the ladder is 6 meters. and 2.5 meters. They're mentioning something about 2.5 meters, and 2.5 meters is distance of 2.5 meters from the wall. So here is the wall, and this is the foot of the ladder. So this is 2.5 meters, this distance. So BC is distance from foot of the wall, distance of foot of the ladder from the foot of the wall. Now if you look up here, we can use Pythagoras theorem. Angle C is 90. So we have angle ACB equal to 90. So AB will be the hypotenuse. So we have AB square equal to BC square plus AC square. AB we do not know. We need to find. BC is 2.5 square, AC 6 square. So 2.5 square is 6.25 plus 36. So AB square equal to 42.25, and AB will be under root of 42.25, and under root of 42.25 is 6.5. Example 12, AD is perpendicular to BC. Prove AB square plus CD square equal to BD square plus AC square. So first we require AB square, right? This is AB square. Let's take a triangle that contains AB square. So I have, this is AB, and I require AB square. So I'm going to take triangle ABD. In triangle ABD, angle D is 90. So triangle ABD, angle BDA equal to 90. So by Pythagoras theorem, I have AB square equal to BD square plus AD square. This is by Pythagoras theorem. I'll write this as equation 1. Now in the next part, I require CD square. Now where is CD? Here we have CD here, CD. So we are going to take up the triangle ADC. So in triangle ADC, D is the 90 degrees. So you have angle ADC equal to 90. Now the hypotenuse will be AC, opposite 90 degrees. So AC square equal to AD square plus CD square. Remember, we want CD. So CD square will be AC square minus AD square. I'll just rearrange this. So I have CD square equal to AC square minus AD square, equation 2. Now if you look up in the question, we need to show AB plus CD. So we have to add equation 1 and equation 2. So we add 1 and 2. So we have now AB square plus CD square equal to plus AD minus AD I cancel, equal to BD square plus AC square. Proved. BL and CM are medians of the triangle ABC, right angle at A. Prove that 4 times BL square plus CM square is 5 times BM square. So in this figure here, we can see 3 right angle triangles. The first one is the largest, that is ABC. And in ABC, angle A is equal to 90. We see the hypotenuse is BC. So by using Pythagoras theorem, we get BC square equal to AC square plus AB square. This is equation 1 by Pythagoras theorem, equation 1. Now the next right angle triangle is BLA. So we'll take up now BLA. So in triangle BLA, again angle A is 90 degrees and the hypotenuse is BL. So we have BL square equal to AL square plus AB square. But it's given to us that BL is a median. This is the median, which means if this is the median, BL is a median, that means L is a midpoint of AC. And if L is a midpoint of AC, for AL, we can write as AC divided by 2. And that's exactly what we're going to do. Here we have BL square equal to, for AL, I'm going to write as AC divided by 2 the whole square plus AB square. So that means BL square equal to AC square over 4 plus AB square. So BL square, take LCM 4, so I have 4 AC square plus 4 is AB square. Cross multiply, I get 4 BL square equal to AC square plus 4 AB square. I'll put this as equation 2. Now we take the third triangle, which is AMC, and we use Pythagoras theorem there too. So we have the third triangle here. So in triangle AMC, angle A is 90, the hypotenuse is CM, so CM square equal to AC square plus AM square. This is equation 3 by Pythagoras. So CM square equal, now for AC I write AC square, but look at AM. AM, you'll definitely agree, is half of, this is AB, this is full is AB. Here this is AB, this entire is AB, and M is a midpoint. How do we know that M is a midpoint? Because it is given to us that CM is median, and median always joins the opposite vertex to the midpoint. This is the opposite vertex here to the midpoint. So M is a midpoint. So that means I can write now AM, this is AM, is equal half of AB. See, this is AM, half of AB. So for AM, I'm going to write AB by 2. So here AM, I'm writing AB by 2 the whole square. So next we have CM square equal to AC square plus AB square by 4. Take LCM. CM square equal to, this is 4 here. So AC square plus AB square. Cross multiply. 4 CM square equal to 4 AC square plus AB square. We'll put this as equation 3, not this one. We don't need this. Now next, remember what we need. Here we need to prove BL square plus CM square equal to 5BC square. So what we will do is, we'll take up BL square, CM square, and we'll add them up together. So here was my BL square Here is cm square, and I'm going to add these equations 2 and 3. So here's my equation 2 and equation 3, and I add 2 and 3. So when I add 2 and 3, I get 4 bl square plus 4 cm square equal to, now there's 1 ac square plus 4 ac square, so this will be 5 ac square. 4 ab square plus 1 ab square, again 5 ab square. I take 4 common out, bl square plus cm square equal to 5 common out here, so ac square plus ab square. So 4 bl square plus cm square equal to 5. If you look up in the earlier, we have shown that ac square plus bc square equal ac square plus ab square equal to bc square. This was by equation 1. So this is exactly what I'm writing. For ac square plus ab square, I'm going to write bc square. And I have now proved 4 bl square plus cm square equal to 5 bc square. Proved. O is a point inside a rectangle ABCD. So here's a rectangle. O is a point inside this rectangle ABCD. This diagram will not be given to you. You need to draw it. Prove that OB square, this is OB square, plus OD square equal to OA square plus OC square. In the first step, we will construct a line PQ that is parallel to AD and BC and passing through O. Now here we'll get 2 more rectangles. If you see, you'll have A, P, Q, D will also be a rectangle because we have these lines AD parallel to PQ. This was 90 because the earlier ABCD was a rectangle. This also will be 90 and this also will be 90. So here I have a rectangle, and on the lower side also this will be a rectangle. P, B, C, Q, D will also be a rectangle. This top one is a rectangle, and the lower are also 2 more rectangles. We have PQ parallel to BC, angle A is 90, so angle APQ will also be 90. Similarly, we have angle D is 90 and angle DQP will also be 90. And if it is a rectangle, I can say now AP equal to BQ. I write this because I'm going to use this later. AP equal to DQ, and I'll put this as equation 1. In the same way, we need to write this, of course. We have not written that it is a rectangle. So we have APQD is a rectangle. And if it is a rectangle, you have AP equal to DQ. Write equation 1, reason opposite sides of rectangle. In the similar manner, I can say PBCQ is a rectangle and PB equal to QC, opposite sides of rectangle. This is one part of the sum. Now we go to the second part of the sum. Now in the second part of the sum, we're going to take up 4 right angle triangles and use Pythagoras theorem. The first one we take is POB. So here we have POB. This is 90. So we have triangle POB, where angle OPB equal to 90. So using Pythagoras theorem, OB will be the hypotenuse. So OB square equal to OP square plus PB square. So we see that this is the OB is a hypotenuse, which will be equal to PO square plus AB square, PB square. We put this as equation 3 by Pythagoras theorem. Now we take up the next triangle. We'll take PAPO. Here is 90 degrees, and we'll use Pythagoras theorem again in this. So in triangle APO, angle APO equal to 90. So here we have the hypotenuse is AO. So we have AO square, it's a longer side, equal to AP square plus PO square. This is equation 4, Pythagoras theorem. Another right angle triangle is DQO. So we have here, so we have triangle now DQO, and the hypotenuse will be DO. So angle DQO equal to 90. So DO square equal to OQ square plus DQ square. Pythagoras equation 5. And the last one we take up is B, not B, that's wrong. We take up DOC. The triangle, this triangle. So we have triangle OQC, angle OQC equal to 90. So the hypotenuse in this case is OC. So we write OC square equal to OQ square plus QC square, also Pythagoras equation 6. Now if you look up in the proof, we have to add OB square and OD square. So here is OB square and this is OD square. So equation 3 and 5 have to be added up. So here we add 3 and 5. Why do we add 3 and 5? Because that's what the proof is asking us to do in the question. So we do OB square plus DO square equal to OP square plus PB square. These are the green ones. And now the orange ones, OQ square plus DQ square. Earlier we showed two rectangles, and in those rectangles we said PB equal to QC and AP equal to DQ. We'll substitute this result in the equation. So if you look up here, we know that PB is equal to QC, and that's what we're going to do. For this PB here, I'm going to put QC. I'll write it out right here, QC square. And earlier we have also shown that DQ is equal to AP. So for DQ, I'm going to put AP square. And the rest I will write as it is, OB square plus OD square equal to OP square plus OQ square. Let me write it again. So AB square plus OD square. Now I'm just rearranging this. I'm going to put OP plus AP together. You'll understand later why I'm doing it. I'll put these together, And now I am left with OQ square plus QC square. So we have OB square plus OD square equal to. Now look at what is OP square plus AP square. It's out here. Look up equation 4 here. What is AP square plus PO square? And that is AO square. So I write AO square here. Plus. And what is OQ square plus QC square? And it's here. So which is OC square. So now I go back. We have OB square plus OD square equal to AO square plus OC square. This is by 4 and 5, and we have proved.